Welcome back to Mimi. We have a small group at the top of the hour. I think we should give people 1 to 2 more minutes. Show up. While we wait, you could think about being our note taker today, because we're going to need one. I'm going to ask really soon for a note taker, but not yet. So you can consider it while we wait.
Quick audio input test. Okay, it looks like it works.
Boy. It was audible, but at least on my end, it didn't sound great.
Let me test again here. Is that any better?
At least to me, it sounds like the gain on your mic is low or something. But I can hear you.
It's coming in fine for me.
Okay.
I'll do the same.
All right. I think we should go ahead and kick off. Sorry, go ahead, Comrade.
No worries. Just wondering, like, just so we don't have to do it later with the mic, I just wanted to figure out if it works. Seems to work.
Yep, sounds good. Okay, we're going to go ahead and kick off. Welcome back to Mimi. Here's the note well. It governs our meeting today and references all of the IETF's policies, including IPR and code of conduct and other things. So please take a look if you're not familiar and stick with the policies. As I previewed, I would be asking for a note taker. Would anybody be willing to take notes today?
I can do it if no one's stepping up.
Thank you, Matthew. And if you can do it in the pad, that would be great.
I shall try to find the pad.
It is linked. It's actually called the note-taking tool. It's one of your icons at the top.
Okay, that was very easy.
Thank you. So here's our agenda for today. It's Design Team Day, so we will turn it over to Richard, Conrad, and Travis to present the five drafts, yes, that have come out of the design team's work. They have kind of 60 minutes of presentation prepared, and then we'll have lots of time for discussion as well. So that's the plan for today. Does anybody want to bash the agenda? Okay, Richard, over to you.
Test. Okay.
Are you running the slides?
I can. Let me see if I can find the right buttons to click to share. Okay. I requested slide share. I don't see an option for the content slides in the Meet Echo slideshow thing. So perhaps I will go grab the original thing and screen share. Sorry, stand by 1 minute.
Yeah, I think what happened is that the protocol deck slides possibly came in too late for the data tracker to be echo sync to go through. So I'm quite confident I added, yeah, I did add them to the data tracker, but they're not showing up amongst the preloaded slides. Sorry about that. But yeah, I think the easiest thing is to screen share.
Yeah, I just sent a request for it, so I think you might have to grant that. Yes. Okay. Can't quite. Tim, I'm going to request one more time if you could just grant that again. Okay. Sorry, I'm having to.
Tim, do you want to try it?
Yeah, I'm gonna in a minute. Just a little, let's just give
Yeah,
Richard
Tim, if you
more
could do
seconds.
that, that would probably smooth this out a little bit.
Okay, hang on while I click some buttons. Yoink.
I think that may have worked.
Do you want to try requesting screen share again then? So I'm not sure what you meant when you said that might have worked.
Sorry, I think I may have shared after you revoked permission. If you have a way to share, I think that would work a little bit better. What I thought was going to be possible here is not looking great.
Okay, give me a sec.
Some bad interaction of Meet Echo and Firefox. Good thing we have such a capacious time slot today. I think we'll fill it.
I might be in the same bind as you with respect to Firefox, no longer wanting to pop a dialog. 1 sec.
Is it showing some info bar that's like, I want to show a dialogue, but it won't let me?
No, it gives me the share screen, so like the window to share thing, but it doesn't show anything but the current window.
Sounds like a bug.
So like I can share a tab in the current window,
Right.
but then I can't see the Meet Echo screen.
Man, if you see something, say something there, Richard. Follow bug.
See something, file something, yeah. I'll have to remember my Bugzilla password. All right, that's looking pretty good from
Email Martin.
Zoom now. Here we go. Innovation.
Wait, Richard.
All right, so cool. So this is going to be an update from the design team on kind of the documents we sent around and some further discussion that happened among the design team after we got those out. So I would consider, as we're going through this, consider the documents kind of a snapshot of where we were like a week and a half ago. And we've had some substantive discussion after that that's reflected in the slides. And in the discussion portion after, we can discuss, kind of where to go in terms of reviewing the documents or adoption or what have you. So next slide, if you could scroll down, please, Tim. The plan for this first chunk of time is to kind of walk through where we've gotten from a design point of view. We'll start from the top as usual, reviewing architectural concepts and kind of map how the current documents reflect that architecture. And I'll walk through those two bullet points, and then Travis and Conrad I'll pass over to. They have worked through kind of how some example scenarios, some very basic example scenarios work in this framework we're arriving at, with the idea that you could, the documents as they exist are pretty close to being able to implement these scenarios. So the idea is to kind of give folks an idea of how the various bits in the documents fit together to actually do messaging stuff. So that's the plan, and then at the end we've got a bunch of time for discussion. Discussion both substantive and what people think about the actual architecture here, and procedurally what we should do about documents and adoption. So with that, I think we can dive in. Next slide, please. So this is just an interstitial slide, architecture. So I published an updated MIMI Arch doc, very lightly updated to reflect a couple of new agreements among the working group. So we'll start from the top here, and it'll get more interesting as it goes along. Next slide, please. This picture should be familiar right now. It's unmodified since the IETF meeting. This is our classic client server to server to server. It's a client architecture where the MIMI scope is this room that spans several servers, and then things between clients and servers are within the provider domain. Next slide. This is also, I think, unchanged since last time. So just to remind folks that we have this concept that each room is hosted on a hub server. For now, we're assuming that hub server is constant over time, that the room always lives in a single place. There is this notion of hub portability that has been discussed, but I think we're punting that for now and assuming that the hub is constant for the moment. The notion of this hub is that all of the communications related to a room go through this hub. So if server A and server B, server A needs to get some information from server B in the context of a room on server C, server A sends that request via server C, not direct to server B. This is to accommodate, lack of full mesh connectivity in the server infrastructure. But the premise is if you're involved in a room, then you've got to be talking to the hub. And so routing through the hub is a safe way to route stuff. Next slide, please. All right, so this is the first one with some new content. On the last call, you'll recall that we had some disagreement over this term member, and whether that should be used for clients or users or what have you. And we've gotten a little clearer on this. So as before, the unit of functionality we have here is a room. A room, in addition, room has messages that go by, of course. I didn't, just kind of left implicit here. The remainder of the information of the room, about a room, we call the state. So that's all the stuff that relates to the what a room is, how it works. It is not all the messaging stuff happening inside the room. And so there's a few components that we have in mind right now for that state. An authorization policy that says things like what users can do, how people can join. A list of users who are participants in the room, the participant list, we'll use that phrase going up forward. And an MLS group attached to that group, so some end-to-end encryption state, including part of that state, a list of the clients, the specific devices who are members of that group. So we've established kind of parallel terminology. So the word member relates to client. So a client is a member of an MLS group. And then at the user level, a user is a participant in a room. So we have MLS, E to E level terminology. We have MIMI user level terminology. Clients, members of a group, users, participants in a room. So there's two kind of lists of things here. The MLS group will have a list of members, and the room will have a list of participants. And we'll talk in a little bit more detail about those in just a second. Once you have this distinction between users and clients, there's a question of whether a user, this distinction allows for users who have no clients joined to the room, so clients who are not members of the MLS group. Sorry. A user who is a participant in the room may have no clients that are members of the corresponding MLS group. So that means we need to distinguish two types of users: users who do have MLS clients in the group, or users who don't. And the terminology we've landed on there is active or inactive. So a participant in the room that has clients joined is active because they can do everything. They have all the state they need to participate in the room in arbitrary ways. Someone who doesn't have clients joined is called inactive because they're going to be more constrained in how they can participate. Yeah, Eric.
So this is probably a way too technical question, but suppose that we have a situation where I am an inactive member of the group, and someone sends me a welcome and a key package, but I have a welcome message, and a join for the group, but I've not yet confirmed. Am I active or inactive?
So
as I understand MLS has states where I can be receiving messages, but I haven't confirmed that I haven't changed the key material, right?
Yeah.
I would say in your example that was active.
Yeah. So at the moment,
but I'm not a member of the MLS group according to MLS specification because I haven't confirmed.
Well, pause a second. When the welcome is generated, or sorry, when a welcome is only generated in pairing with a commit, right? So there's some member of the group issues a commit that adds you to the group, and in parallel causes a welcome to be created that your client can use to initialize itself, right?
Agreed. But my point is that I have not taken any activity to make that happen.
Correct.
And as I understand the way the MLS spec is written, that is not considered a member of the group.
Well, at the moment, in the epoch that commit initiates, your client is a member of the MLS group. So when that commit is accepted by the clients in the room, then your client will be part of the MLS group and you will be an active user. So yeah, a user can be activated without any action on their own besides providing the key package.
Okay, maybe we take this offline.
Yeah. I mean, that touches on the question of consent. Under what circumstances can Eric be added to a room, or Eric's clients be added to a room, which I think we have not dived into a whole lot. In particular, we punt in the examples we've got here today. But it's a question. It's a good question. We'll need to work out the nuances of that as we go. The last thing I want to touch on this slide is that in earlier discussions, we talked about something called a policy envelope. That I think is a little ambiguous. I think we need some more refinement around that. We need to, the policy envelope, I think with the idea when we talked about it before, was a thing that the hub would specify that were the immutable parts of the bounds on the set of acceptable authorization policies for a room. The stuff I think we have right now talks about the policies themselves, and we may need to revisit this notion of a policy envelope instead of acceptable policies. So just flagging that as something that needs some further work. Next slide, please. I thought it would be useful to visualize this. Actually, I'm borrowing from some visualization that Travis put together and Conrad. Right, so this is just visualizing the state of the room. Starting from the right is the most concrete thing. The MLS group is the set of clients that have the keys for the end-to-end encryption of the room. There is an assumption I think we've been making along that I meant to document these slides and I forgot to, that each client, based on their representation in the MLS group, from that representation, it is possible to infer which user a client belongs to. And so there's actually a mapping between these clients, which I've implied with the numbers, but meant to put lines. Should have drawn lines so there's a mapping between those clients in the MLS group and the participants in the participant list. And as you can see in the participant lists, user one, we've got 3 users who are possibly participating, who are participants that have a relationship with the room. User 1 and user 2 have clients joined, and so they're active. User 3 doesn't, and so they are inactive. But all 3 of those are, because they're in the participant list, they can be subject to, they're part of the room, and so they can be part of the policy structure of the room. The room can have a notion of what capabilities each user has, and so they can say that user 1 is an admin, or user 2 is a moderator, etc. And the policy document also captures things like the admission policy, how it's possible to join, and other kind of authorization, things like that. So we split out this structure because we're actually going to build protocols kind of in parallel to manage the different bits of this. Next slide, please. So one of the consequences, though, of splitting out the room state like this and building independent protocols to manage the different bits of state, the benefit of having separate protocols is that each protocol can do what it's good at. So MLS is good at managing a cryptographic, some group cryptographic state, not so good at managing authorization policy. So we have separate, horses for courses for the different bits of state. The downside of having separate management of these things is that those things can get disconnected, that you could have, in principle, a participant list that was inconsistent with the MLS group. So in addition to splitting things out and managing things, being able to manage each thing independently, we need to define how these things interlock with each other a little bit. And this was a point of some discussion in the group, but I think we've aligned pretty well on this kind of preemption rule, as I've put it here, that there is a kind of hierarchy to these bits of state, that the authorization policy is what governs who can be a participant, and among whatever else the authorization policy governs. And then the participant list acts as a boundary on the MLS group. So in particular, the MLS group is kind of a subject of the participant list in that you can only have a client in the MLS group if you're a participant in the room, right? So each client in the MLS group, the user of that client needs to be a participant in the participant list. And obviously this has some implications for order of operations that we'll touch on in a couple of slides. The next thing to talk about, next slide, please. One of the concepts that comes out of using MLS, that came out of the kind of DS sphere, is this idea of confirmation. So we're kind of pulling this out of the MIMI DS work and abstracting and pulling it into this architecture. One of the things you'd like to assure about this room state is that everyone involved in the room has the same view of the state. So all the clients and all the servers have the same view of the room state. Now that's, as with anything that can change, there might be some time lag in this confirmation, but the goal is to keep this, to confirm that we all agree with some fidelity to some proximity to the changes that happen in the group. So the way the mechanism proposed here is to use the MLS key schedule as a confirmation mechanism. So in case folks aren't familiar, need a reminder, if you inject a value into the MLS key schedule, that value gets hashed into the state of the MLS group and thus into all of the keys that the clients use. Which means if you disagree on this value that you hashed into the key schedule, then you can't communicate. Your keys will all be different. So the concept for confirmation here is to take the whole room state, including the MLS state already goes in by virtue of MLS, but to also take the authorization policy in the participant list and hash those into the MLS key schedule, so that in order for the group to continue functioning, everyone has to have the same view. Now, functionally, how I think we expect this to work is that we'll have some group context extension using some existing stuff in MLS, extensibility points. And And then each commit that is made to update the MLS group to reflect new changes to the room state. If a user joins and we want to add some clients for them, each commit will be enforced by the hub to reflect the current room state. So that we'll have to carry one of these extensions that updates the MLS confirmed state to match the current room state. The way I've drawn the blue arrows here is perhaps a little confusing. What I mean there is that the MLS group will have some extension that is a hash of the rest of the room state, and so that will confirm or vet via MLS the participant list and authorization policy. So the MLS state, if you agree on the MLS state, that means you agree on the participant list and you agree on the authorization policy. So again, this is another thing that will require a little bit of specific order of operations, because if you're going to require reasonably fresh confirmation, then you need to do some commits to keep the confirmation fresh as you make changes to the room. Next slide, please. Yeah, oh, sorry, Ecker.
Yeah, I just want to make sure I understand this slide. So these arrows really mean, so the arrows on the top mean information flows, the red arrows mean information flows downward, and the arrows on the bottom mean look over here because I'm incorporating that data into myself, right? So actually the information is always flowing downward, right?
Yeah, I think that's a fine way to think about it. Yeah.
Okay, great.
Well, I mean, it's a little bit circular in the sense that the authorization policy governs the participant list, which governs the MLS group, but then the MLS group confirms, this hash that's in the MLS group confirms that what the authorization policy and participant list were the last time we made an update.
No, but it points to them, I guess, is my point. It's not reincorporated. So there's no MLS message which you would send, which would change the authorization policy. That'd be on some other layer, even if they were linked up somewhat.
Yeah. The control flow of left to right. The confirmation is right to left.
Perfect. Thank you.
Okay. All right, next slide, please. Yeah, so order of operations. So these invariants on the last couple of slides, they're useful in terms of clarifying what we mean, but they have some implications for how we do stuff. In particular, if you think about joins and leaves, things that are going to touch both the participant list and the MLS group, they have to be done in a particular order. So when I'm adding Ecker to the room, right, I'm going to want to add Ecker as a user and some of Ecker's devices. And so if we're going to have this preemption order in the, as the kind of orange arrows indicate, then I need to make sure that Ecker is added to the participant list before I add his clients. Because if the MLS ad shows up first, that Ecker won't be in the participant list and that commit will get rejected. So we need to do ads at the participant list level first and then at the MLS level. And then when I'm removing Ecker from the room, it's the reverse. So I need to make sure all of Ecker's clients are removed before Ecker can be removed from the participant list. Because if I remove him from the participant list before his devices are gone, then he's actually not, he's kind of still a participant because he can still get access by those devices. So the idea is to have the participant list reflect, the people who have some chance of getting this stuff, and have the MLS group be, no larger than the participant list. And so we have to do these operations in that order to maintain that invariant. Yeah, Ecker, is this a new comment? Or are you stale hand?
Great. So, I mean, this is definitely one way to design the system. But I'm not saying that I think there's that other way is better. But let me pull it another way, just so we make sure we've considered it properly. So, another way to design the system would be that some external party which controls the participant list, right, or controls the authorization policy, and the operator of the messaging service, and it says, well, I'm kicking Richard out of the thing, right, and it hits the participant list, and then that triggers some member of the group to says, well, members of the group, the first person to see this ought to do an MLS commit to fill them out of the group, right? I'm not sure that's a good design. I just want to point that as an alternative, and I think it'd be worth talking about why you rejected that. And if I just say one more thing, which is, one might imagine that there were and I of course am like Team MLS, so I'm happy to only work with MLS, which has this functionality. But one might imagine there were cryptographic protocols which did not have a mechanism for an external party to evict someone from the group. Do you even propose it, right? Because this relies on there being like an MLS mechanism that says, person who's not in the group, I'm supposed to throw Richard out of the group, right? And when I imagine there were protocols that didn't have that property, in which case it's not clear what you would do.
Well, you can only do that non-cryptographically, right? You could have some, just a message, message authenticated from the server that says, dear client, please evict Richard.
Yeah, you both on top of them on that thing.
Yeah.
So yeah, I guess I said I don't feel strongly with this, and I think this is a reasonable design. I'm just like trying to explore the space.
Yeah, and I'll let Rowan talk in 1 second. But I think I think the design team thought about that some. I think the thinking was that it would be clearer, rather than proactively removing from the participant list while that request was pending to remove the devices, to instead keep them on the participant list, but maybe annotate it as being in an exiting state or something, and then actually remove once the devices are removed. But Rowan, do you have some further thoughts here?
Yeah. So that's exactly what Richard described, is exactly what I proposed. But I wanted to comment specifically on the, to MLS or not to MLS. So what we described, the compromise that we came to, was that there is, basically a Lego block of stuff that manipulates state and the end-to-end encryption. And in the case of MLS, the MLS chunk that, the end-to-end encryption has a bunch of stuff which also manipulates state. And so the set of things that you need that are outside of MLS are fairly small and possibly could be made to be zero. If you did this with double ratchet or some other protocol, then the Lego block still has the same boundaries, and the Lego block includes something that goes and basically does an encryption of sessions and things that in some other stuff that manages the state of your, in this case, your mapping of the participant list to specific sessions. So you can totally do this with another protocol if you want to, but that's not in our charter. But we have made, we have been striving to make sure that is possible and, doesn't blow your head up.
And that's an excellent transition to the next slide. Oh, sorry, Echo, you go ahead.
Well, yeah, maybe this is the next slide, but I think there really is a group decision to be made, which is, do we assume that the outer contours of what is required in this Lego block are effectively what MLS provides, and that anyone else has to figure it out on their own, and we're not going to help, basically. Which is basically what Quick did with TLS, right? Is Quick was basically designed to have a TLS-shaped hole, and it was your responsibility if you want to put anything else in there to put it in there. I think it's a fine decision. I think it's, in fact, the appropriate decision, but I just want to call out that's a decision we should really explicitly make.
Yeah. Yeah, so can we go to the next slide, please? Because that is my Lego bricks slide. For what it's worth, I looked up I checked the official terminology that the Lego company prefers, and it's bricks, apparently, is the, not blocks, is the official name. I also found the etymology of Lego at the bottom, which is about playing well, which I thought was a very appropriate, admonishment for folks in the IETF to play well together. But this is kind of the Lego brick model that the design team has been referring to in our discussions in terms of what protocols need to exist to make this system go. And this is a bit in the architecture document, but I think this diagram probably needs to get imported into that document in the next rev. So right at the base of all this, we have some transport that ships messages around between servers. It's pretty lightweight at this point. It's just a framing thing. then in these blue blocks, well, I'll cover the right hand first because that's the simplest thing. So there's some messaging forwarding protocol that just like fans things out as you would expect, fans end-to-end encrypted things out. That end-to-end somehow touches the message, sits between the message format and the forwarding, but that was inconvenient to draw, so I didn't draw it over there. But the presumption is that messages, things that are in the message format are carried in some end-to-end encapsulation and then delivered over some forwarding protocol. The interesting bits here, the parts that, if you've been following the last few slides, are these blue blocks for the different protocols that manage the different groups of state attached to a room. So like Rowan said, we have this end-to-end thing, which is managing in, IETF-MIMI, an MLS group. And I think Ecker's, the way Ecker framed it is accurate, it corresponds to the way the design team has been thinking about this. This is an MLS-shaped hole. And if you want to do this with some other protocol, it's up to you to figure out how to, add whatever filigrees you need to make your thing do the things that MLS does. So like confirmation, that's that sort of hashing into the key schedule doesn't exist in a lot of other protocols. So if you wanted that security benefit, you might have to do that. As an aside, I might say that like a lot of the things that MLS does, you could do non-cryptographically and get lower security properties. So it wouldn't be surprising if folks coming to this with a different protocol did things like proposals, but without some of the confirmation security properties that MLS gives you. So anyway, we've got an end-to-end block which manages the cryptographic state, the end-to-end security keys. We have a policy layer. Sorry, I've put these in a different order than the state bits on the previous slide. That would have been helpful. A policy bit that manages the authorization policy, and a signaling bit that manages the participant list. I've written this gray block with application logic because there's going to need to be something in the software implementing this protocol that ties these things together and ensures those policy, those interlocks we talked about on last slide. I think that's not written down in the current documents except for how it's captured in the architecture document. So speaking of documents, if you go to the next slide. Sorry, Alyssa, yeah.
So when you talk about the MLS shaped hole, do you think the hole only touches that one box? Because in reading the drafts, it feels like there's actually like quite a bit of interlock between these. Like the transport protocol might be designed differently if you weren't using MLS. And so I'm just curious of like, when you say the hole, like which parts of this does the hole extend to?
I think the aspiration is to, I'm just noticing Ecker's comment in the chat. Well, I think mostly this
Whatever, forget about the diagram, but you see what I'm saying is like
yeah.
How much of the overall architecture is impacted when you say someone can do this without MLS? Because to me, it seems like most of it. So I want to know if I'm wrong, basically.
Well, I think the compartmentalization objective here is for it to be like not an inordinate amount of re-engineering to reuse the policy and signaling and transport bits with a different protocol for the end-to-end security. Now, if that requires that you implement some, imagine that like the message encapsulation or the transport reused some MLS data structure that you would get naturally if you had an MLS stack, but you might have to implement that data structure with a different thing. Like that may be a little bit of infection, but it's not an inordinate amount of work to add that to your existing crypto thing. Like I was saying a minute ago, like MLS is a little bit, has a bigger envelope. It's going to leave a bigger hole than most other protocols that are of its general shape. And so if you're starting off from one of the other protocols, you're going to have to add stuff in order to do something comparable to MLS. So yeah, and there's going to be work even if it's just confined to the end-to-end thing. And I think there's bits to touch, but I think the objective is to make them reasonably small and not in kind of tying in all of the complexity of MLS. But I'll go through the queue. Ron?
Yeah. So I can give my version of what I think the answer to that is, Alyssa, which is that, I kind of imagine the policy blue block is independent of protocol, and that the end-to-end encryption and the signaling, they have they touch each other, but the size of them, basically they need to be sort of a matched pair. But the interfaces that, the interfaces to the application logic could be the same for a matched pair of MLS plus MLS related signaling, compared to a replacement double ratchet and double ratchet related signaling. So those two pairs could have an equivalent lower interface and upper interface. And then, of course, message forwarding relies on end-to-end encryption. So I three bricks is my answer. I hope that helps.
Okay, Tim?
Okay, so granting that we could design some sort of abstraction over a specific E2EE mechanism that would allow either like MLS or something like double ratchet to be used, what does all this mean for interoperability? Is the idea that participants would have like previously agreed out of band that they're doing either double ratchet flavored MIMI or MLS flavored MIMI?
For the IETF, it means nothing. We are going to make MLS flavored MIMI. And if other people want to vary, they're off book and it's up to them.
Okay, so yeah, no expectation then of like in-band negotiation of which kind of E2EE to use. Okay, thanks.
And just to add a little bit on there, I think the again, talking about objectives here, and maybe if Matthew wanted to come up and say some stuff about this, but I think the idea is like if folks want to use some drafts here that they might be able to take up some of the transport or policy or signaling bits that are a little bit more independent before they're ready to buy off the whole complexity of MLS. That's the idea. It's a theory, but I think Matthew has some more thoughts and he's in the queue. But Ecker?
Yeah, I think so. I think what I got to say, we like largely what you just said a minute ago, not what you just said, but you said in response to Tim, namely like we are chartered to design something that uses MLS. And as a matter of good design principles, it is useful to like design something where MLS is coupled to the appropriate level, which is not at all coupled and not totally intertwined with with the rest of the protocol, and that is a set of judgments. And it's not. I don't think it's your responsibility as working group to like go to extensive efforts to make that removable. But we should. But like, there's no need to go to extensive efforts to make it not removable either. And so I think when I said MLS should hold, what I meant is we'll design the system assuming MLS is the way it is, and we can depend on everything that MLS does. And if if you want to build something that is supposed to fit into that hole and you don't want to use MLS, then that is like your responsibility to fill in all the details. And like, in particular, I don't think we should write like a document that like defines an abstract API that like if to do, it's like you're just like you just drop in. It's like not really our problem, right? And so and so and Richard and to Alyssa's point, I think it's entirely appropriate to sort of in other parts of the document say because this is carrying MLS, we can get away with X, Y, and Z. And obviously, as I think I mentioned to you earlier offline, Richard, like that like MLS somehow like is actually under in between message forwarding and message format in some unspecified, unclear way. So there are there are tendrils of MLS all over the system. I think that's entirely appropriate because it's a basic invariant.
Yeah, and just to extend your quick analogy from earlier, if someone wanted to make a quick based on WireGuard, they'd have to like figure out how to make WireGuard look like TLS to the extent that.
Yeah, and people have done in fact done the specifications. I don't know how good they are, but it wasn't like an objective or quick to like go to a lot of effort to make that possible.
Yeah. Conrad?
Okay, no worries. The risk of getting a bit technical, but I assume that we're going to, for reasons of good practice, we're going to have version interleaved anyway. There's going to be a version probably at the first field of any kind of high level struct, and so if you then want to abuse or use this to define your own versions somewhere in the field where no other version will be, then you can use that, and that essentially gives you the kind of negotiating capability, if you want.
Matthew. The extended mute echo mute button. Oh, maybe we lost Matthew. All right. Any case, I think we can move on at this point. Next slide, just kind of. Oh, go ahead. Matthew.
Sorry, yeah, the mute button literally vanished from the DOM somehow. Yeah, well, what Conrad said was what I was going to say about agility. Obviously, you need version agility in here anyway, and that can be used to describe different dialects of MLS or double ratchet or whatever it is. In terms of the kind of transitional benefits, I think there is a real opportunity to be had here by going and making the Lego blocks interchangeable in terms of just practically getting uptake for this protocol. Right now, people are speaking double ratchet, and frankly, getting the gatekeepers comfortable with the idea of using the consistent policy and signaling and message forwarding and transport modulated bits, which do have dependencies on the crypto block, stops the risk of folk implementing their own proprietary vendor-specific APIs in the short term for DMA compliance, or for that matter, using a different interim solution that then gets replaced, that hasn't got the traction of something like MIMI, because it's seen as a transitional effort. Whereas if MIMI can support the transitional use cases, I think there is a much, much higher chance of it actually going through and being adopted by everybody, rather than just through specification pressure, particularly as there isn't regulatory pressure at the moment to talk a common language.
So just vis-a-vis what everybody else in the queue just said, do you feel like what you just said is consistent? Like people were talking about there being, you know, some dependency, but like, you know, we scope the size of the hole, and then like people want to use something else, they use something else. Or are you advocating for like more decoupling than what was just discussed?
No, I think that the proposed decoupling is sufficient from what
Okay.
I've seen, unless the goalposts are changing from since we last spoke about the specifics on it. And I think it's completely reasonable that you need a confirmation mechanism, and MLS gives a great confirmation mechanism. Other ones also exist, like the one we proposed in linearized matrix, that can also be used to fill that hole. But I think this strategy of saying, look, it's an MLS-shaped hole, you've got to figure out how to fill the gaps. If your protocol can't fill the gaps, then perhaps it has weaker security properties, frankly acts in the interest of both MLS and MIMI by there being a kind of potential gradient that is dragging people towards the promised land of MLS, that at least provides a transitional route to do so.
Okay, thanks.
Yeah, how exactly we achieve that right degree of coupling or decoupling has been an appreciable amount of the time that the design team spent discussing. So last slide I had here is just mapping the documents that we've got now to these Lego blocks, just to show that, you know, hey, we have some coverage of this in the documents. Now, unlike actual Lego bricks, these documents don't fit super nicely together right now. As you read through them, you'll notice there's some disconnects in your assumptions, and some disconnects with what was in the preceding slides, because this reflects some more recent discussion. So I think the idea of the next section, where Travis and Conrad are going to kind of walk through some scenarios, is to give an idea of where you know, where we've ended up as a design team on how things ought to work within this framework we've been discussing, as a direction for where these documents should be headed. All right.
This like architectural diagram seems like, you know, modulo my not intended as a factual statement seems like largely accurate. I think it should not be used as a guide to which drafts ought to exist, a la Conway's law. I spent some time this morning going through those drafts, and one, I think there may be some reasons why they don't fit super well, but frankly, it's incredibly difficult to like have like things spaced out so much. So it's like this depends on this and this depends on this, and you got to read them, and they're all quasi-independent. So like I do not think given that we have given there's no intention of like being able to demount all these different blocks, I think we should be trying to consolidate the documents as much as possible rather than have like 6 individual documents, each 3 pages long, which is kind of the mission now. So I think that may part of the reason why the fit may be rough is precisely because of the sort of Conway law effect.
Yeah. All right, that's all I have. I was going to pass over to Conrad and Travis to walk through some scenarios now.
Sure, yeah. If we can head to the next slide, please. Scenario discussions is kind of where we're at. As Richard mentioned in the introduction there, we had 2 scenarios kind of laid out here, just to kind of show like what's going on between the documents themselves. First one here being Alice adds Bob. Second scenario will be Alice leaving that group. So if we go to the next slide, we will start to see some assumptions. Here we are assuming that Bob's service-specific identifier has already been discovered in some way. So we are past the point of identity. We are now strictly into protocol side of things. As well, we're assuming that any consent that Alice needs to add Bob to the room has already happened or is implicitly given. There are multiple layers where consent could be asked for or achieved, but they're all granted in this sort of aspect here. There's also many other types of join flows. This is just one example of many here. We'll kind of head into the next slide here with all of that as a qualifier. So the very first step is that Alice has to create this actual group or room. This happens outside of MIMI. They just create it with their provider, but it does have all of the initial state required for MIMI to operate. So this is the participant list, this is the policy, this is the actual MLS group itself, and all of that stuff. But Alice does have the optional ability to add all of their MLS clients to the group at this point. Not strictly required by the protocol, probably a good thing that should happen. It does happen. So now we're going to head into some diagrams here. If we go to the next slide. So following that preemptive work or that preemptive workflow that Richard was mentioning, signaling happens first, for lack of a better term. So first, Alice needs to create the signaling event to actually invite Bob into the group, or into the room, rather. All of this invite stuff, as mentioned, could just be skipped if we use a welcome flow instead. That's another type of way of joining, but we're skipping that part and we're covering specifically the invite and then join as separate operations here. So first, Alice creates the invite event for Bob, and then next slide, please. Alice has to send that invite to the hub itself, and that will then start to get fanned out. So if we go to the next slide, we're going to start seeing that the hub is establishing that secure connection between what is Alice's server, because Alice is the hub in this scenario, and Bob's server. And then if we go to the next slide, the fan out actually starts to happen. So that invite event is now being received by Bob. And on the next slide, we will see that actual invite being checked. Again, we're assuming the happy path here. So this is where you would check for policy support. Does Bob's server even support the type of room that is being discussed here? Is the policy okay? Is the encryption supported? Is there consent? All of that stuff happens here. We assume that everything is okay, and move on to the next slide, where we then have, again, another implementation-specific detail here, where or outside of Mimi, where Bob server stores that invite and eventually gets it over to Bob through whatever vendor specific API and that sort of stuff. And then if we head to the next slide, some amount of time will have passed. Bob will accept that invite and will start to create this join state or the signaling state change. So we're still well within signaling here. MLS or the MLS group only has Alice's clients in it. Bob is still in the invite state here. On the next slide, that join will head back up that secure channel from the transport into the hub. And then on the next slide, the hub will distribute that back out to all the other servers, which currently only includes Alice. So it also goes back to Alice's clients. And then we head into the actual MLS bits. So I'll hand it off to Conrad for this, where I think he'll be able to cover that in a lot more detail than I.
Sure, but I think first Rohan was on the queue. Rohan.
This doesn't resemble at all what I thought we agreed on in the last couple of calls. I think what we discussed was that this purple signaling would happen simultaneously with the end-to-end encryption, or could happen, or most likely would happen simultaneously, and not as this happens first and then that happens second.
No, a good point. I was starting to get to that. So we chose the kind of the external commit based adding Bob flow, where a lot of non-MLS stuff happens before Bob then kind of inserts themselves into the group. In the welcome based flow, the Alice will probably send the welcome together with the hey add Bob signaling message. We kind of chose this presentation to show kind of the signaling route first, and then if you go to the next slide, we start seeing Bob's server, kind of the hub sending a group info to Bob's server, and this could be the hub could send the group info along with the Bob invitation signaling message to Bob's server if that is desired, I guess. But for now, we've kind of modeled it. We've wanted to show it separately. So this is the kind of MLS part at work. Bob needs a group info to join the group. Note that, like, as a small kind of aside, the group info has to be current. So while the hub could send the group info along with a signaling message, if Bob is offline for a while and the group evolves, in the meantime, Bob would have to get a fresh group info anyway to join externally. So the hub sends the group info over the transport, secure transport to Bob's server. Then in the next slide, the Bob server forwards it to Bob. And then you can go straight to the next slide where Bob does an external commit and sends it right back to its own server. From there, in the next slide, it goes over to the hub via the transport. Sorry for all the scrolling, Richard. Where the hub processes it and forwards it on the next slide to Alice, or to, I guess, everyone else who's in the room, all the other servers. And also, sorry, could you go to the next slide, please? Also, as you can see in the room state on the hub, now Bob's client is actually in the room. And the external commit message is distributed to all the group members. Sorry, there was, no, okay. Sorry, I thought someone was raising their hand. Okay, and I think that's pretty much it, Richard.
Hey, Conrad. Just kind of following on a bit to Rowan's question, I was wondering if you could comment on where the confirmation happens in this process you've laid out. So at what point does it get confirmed by the MLS group that Bob is now a participant in the room?
Right, okay. So the moment that the hub processes the signaling message that Bob is added as a participant, even in the invited state, not even in the confirmed kind of join state. The hub would then require that. The hub would require that the next commit would already kind of feature the updated participant list as part of the group state. So either that's part of the group state as a group context extension, or injected as a PSK, just to make sure that whoever does the next commit agrees on the participant list, that this agreement is then essentially it becomes part of the group state. Eric.
So in the flow you've laid out here, the hub would require the external commit that Bob provided would have that confirmation that Bob is in fact a member, which seems a little circular, but I don't think is actually.
Yeah, Eric.
Does that sound right?
Yeah, sounds right.
Okay.
Yeah. So I guess maybe I just don't have it all booted in my head, but I'm like somewhat uncomfortable with this notion that the hub is doing a bunch of enforcement MLS invariants. That seems like maybe that's possible, but it seems like none of these documents had rules anywhere near clear enough to implement a hub in order to do that, as far as I can tell. So I guess, I would ask first, is that really necessary? And what happens if we don't do it? In particular, second, is it possible? Namely, for instance, is it possible for participants to pretend they're meeting the invariance but not really to meet the invariance? And if not, and if it is possible, then what is the value of the enforcement? And third, how complicated is it to actually specify the rules for what is in fact possible?
Yeah, all good questions.
To give just one example, I mean, I add somebody, but I give them key material, which is bogus. It's like, in fact, they're not a member of the group, right? And going back to the discussion we had earlier, until they've actually responded, then they're in some liminal state where nobody knows the situation is. And how do how can enforce that, right?
Right. I mean, the bogus key material question, that's a question for on the MLS level that's just unsolved on the MLS level, right? I mean, you can always send bogus.
No, right. But I guess my point is that the MLS state in the right, exactly. That's part of what I'm getting at is to what extent, what is the hub verifying this stuff doing? What is the function that hub verifying stuff is doing in this protocol? What happens if it just doesn't do it at all?
So for now, the hub is mostly verifying that the participant list is injected into the group state in one way or another by whoever, after a signaling event has reached the hub and the hub has kind of blessed it and fanned it out to everyone else, then it requires that it's reflected in the group state. I like to think of the signaling messages as you can implement them using proposals, right? It's just like fanning out a proposal, and then before the next commit has to commit to that proposal, and the hub will not accept any other commits that do not include this proposal. And what we're doing right now to kind of keep the signaling somewhat separate from MLS, for now, is that we we might reinvent some properties of proposals, but I think for all intents and purposes, you can think of it as a proposal for now, at least in terms of semantics.
But I guess what I don't understand is what's the functional. You told me we're doing it technically, but I'm asking what's the function of that? Why not just not do that?
It's to ensure that everyone agrees who's on the participant list, and to avoid these kind of weird splits where one group member doesn't think Bob is in the group and the other one does think Bob is in the group, and then suddenly Bob joins and one group member will think that's illegal because Bob's not on the participant list, and another group member says, oh, that's fine, Bob is on the participant list. And so agreement on the participant list is vital to enforce policy. At least that was my understanding, not being a signaling expert. I don't know, Travis, if you want to say something, or Richard.
I was going to up-level this a little bit and note that at least mechanistically, this is not a crazy ask. So a lot of the reason we have a central hub to start with is so that it can act as an arbiter for which commits get applied to provide the sequencing that MLS requires at a base. So the base function of a hub from the MLS point of view is to act as an arbiter of commits. right? If Conrad and I send commits at the same time, one of them has to win, one of them has to lose.
Right.
That's
But that's right. But that's a non-adversarial function. And
correct.
And so, is this an adversarial setting?
No,
either order would be fine in those situations, right? The hub could send could prioritize commit A or commit B, or in fact could delete both of them, right? And what I'm trying to understand is like how what state of affairs could you get into where the hub would be rejecting some set of messages as not matching the alleged state, and can you guarantee the hub can detect every single instance of that situation, or only some of them? And if the answer is no, then I'm not sure why we're doing it at all.
Well, let me. I think the high level point here is like these rules need to get written down in some document.
Well, I think not just rules. Like I think like
the corresponding, justification.
The security guarantees is intended to provide.
Yeah.
Is what I'm asking for.
Hey, Conrad, for your benefit, I think that the salient counterfactuals to look at here is like, yeah, imagine the hub were not enforcing this invariant. The members could still agree. And then what's the difference with that scenario? So I think we just need to drill down on that and get precise on why we need the hub involved.
Good point, right? I mean, we could have agreement just based on the members. But that can lead to situations where you have a kind of an insider in the group, and the insider can send like, and I mean, we have the problem to a certain degree with MLS anyway, but the insider can kind of derail the group by sending an external, sending a commit that's illegal in the eyes of other clients, but the hub says, I'll take it, whatever. And then it registers the epochs forward, and then everyone disagrees with that commit, discards it, but the epoch's been registered forward, and now the hub's in a state that the clients are not in, and like that's. So we try to do, I guess, a lot of like as much verification as we can do on the hub side. But I agree that we need to write this down formally and spell out what security guarantees we expect. Yeah. Are you in your queue again, or still? Oh, sorry. Okay. Yeah, I think this is the end of the first flow. Richard, if you could go to the next slide. Oh yeah, I mean, pretty much. So Alice and Bob can now converse, and then I think we can. I don't know, Travis, do you want to say something more on this slide, or do we want to go to the next scenario?
Yeah, I mean, after all the invite stuff happens, yeah, they can finally send messages to each other, and normal MLS operations happen. It's worth noting that the signaling side of things, so when Bob is in the sort of joined state there, if Bob adds through their provider another client, they can add that to the MLS group without talking to signaling at all. They can just do that. They can also remove all of their clients or one of their clients, whatever, without impacting the signaling side. All signaling's doing there is making sure that Bob, as a user, is at least a joined participant in the group to allow those sorts of operations. But if we head into the next scenario, we can talk more about like what happens when at the user level, somebody wants to actually leave. Is there anything else that you wanted to cover, Conrad, before we jump over?
No, go ahead.
All right. So if we head into the next slide, then we will have some even more assumptions based off of the previous discussion there. So in this particular scenario, we're building on top of what we just established. So there's a room with Alice and Bob in it. There's some clients for both. They're able to converse, and Alice's server specifically is still the hub for the room. And so on the next slide, we're going to see that Alice actually wants to leave that room. So this starts with a signaling event again. And again, like this can also be stapled together, both the DS and signaling operations. We've just split them out here for at least visibility purposes, but there's nothing necessarily constraining it to be separate operations. They could be happening at the exact same time here. But yeah, starting with the signaling, Alice generates a leave event, sends that to the hub server or their own server. And then on the next slide, we again use that secure channel, but as the leave event is being fanned out, the hub needs to require that all of Alice's devices are actually leaving the group here, because Alice has no right to continue in the MLS group now that they're evicting themselves from the room as a whole. So on the next slide here, I think we had a minor color coding issue. Or no, I'm just not staying in sync. All right, so yeah, so Bob receives the leave event from the server that was found out from the hub, and then on the next slide we start to get into the MLS side of things for Conrad to cover. You're suddenly mute for me. I can also try and cover this if that would help.
Yeah, it sounds like Conrad's having connectivity issues, so maybe go ahead.
All right, I'll keep an eye on the chat for live corrections. So yeah, the MLS commit to remove all of Alice's clients here happens. So Bob does that just because Bob happens to be the only other client or user in the room. If there was a third user or any infinite number of combinations of other clients, they could do this as well. But since Bob's the only one, Bob is the one that gets to do it. So Bob sends that to their server, and then on the next slide, that commit makes its way to the hub, as should hopefully be no surprise at this point. And then on the next slide, Bob's commit is sent to Alice, but Alice can't really fully process that commit. But they do learn that they were actually removed from the MLS group. So now they have the state knowing that they are no longer in the room, and that all their clients have been evicted as well, which is good news for them, because that is the intention that they wanted. So on the next slide, we have a bit of a constraint here where it is no longer hello world. They can no longer communicate with each other, at least in this room. But there is the interesting point that Alice's server is still technically the hub for this room, but they don't really have a stake or anything in that room. So we may or may not need the server or the hub server role to transfer of some variety to another server. But this is something that the design team hasn't had a lot of opportunity to discuss yet. So it's kind of up in the air. We'll have to figure it out, I think, a little bit more and work through it. But yeah, if we head to the very last slide, I believe we now get to have conversations about the previous 40-something slides. I guess, yeah, if Richard, you want to introduce this particular section.
Yeah, I was actually going to ask a question about the remove flow. Imagine that there were both, either the room had 3 participants, Alice, Bob, and Charlie. In the one-to-one case where Bob is the only remaining participant, it's clear that Bob needs to do the commit. And I suppose that in principle, if you just kind of announced that the that Alice had left and her devices needed to be removed, you could kind of let Bob and Charlie decide on their own whether they wanted to commit and just kind of throw it out there. What gets committed gets committed. It's up to the hub to decide. Or, I mean, in principle, the hub could designate someone to, some among the first few clients to come online roughly simultaneously, which of them should be the committer. Didn't know if folks had opinions between those options.
Maybe I can jump in here. It works now, by the way. I don't think, like, I don't have a particular opinion in terms of the flow there, but I do think the hub should require that the next incoming commit should remove Alice, because otherwise, if Alice, stays in the group with kind of weird clients where a new user joins the group, user joins the group, adds a client, and then sees, oh, there's Alice's clients, but Alice is not on the user list. So what does this mean? Like, who is Alice? So I think the hub should require whoever does the next commit, if maybe the hub could kind of pick someone and who they then do the commit or something. I'm not sure that that's maybe a technicality, but Alice should be removed in the next commit. Basil?
Yeah, I have a different question. I mean, the flow that you mentioned here kind of seems the opposite what we introduced earlier, like where we talked about removing Alice's clients first and then removing her from the group. I'm wondering if that was kind of a conscious decision, or there are technical limitations that we couldn't go down that path.
From the
Travis, yeah,
sort of perspective, it doesn't really matter whether Alice finds a way to sort of self-evict first from the MLS group or evicts from the signaling side first. It's just laid out as signaling first in the diagrams here, mostly to have consistent ordering between the two scenarios. But like I introduced in the original flow there, like this could happen simultaneously. It could happen in a different order. Leaves are a bit of a special case in this sense because they can happen out of order from the preemptive model that Richard was discussing, whereas things like joins and nots and all that might have to happen in a very more specific order.
Well, I mean, the reason is, like, if we have the user leave but their clients are still in, then the room is not in a consistent state, right? And so that's that's why we kind of discussed that you can always have the user as a participant in the room, but you can't have without any clients, but not the other way around.
Yeah, I mean, Richard had a proposal for that. Richard, do you want to talk about this collaborative approach versus the preemptive approach?
Yeah, well, going back to what Basil said, I thought what we had discussed on the design team call made sense, where the signaling message in advance of Alice's clients being removed would not actually remove Alice from the participant list, but rather put them into some some exiting state where they would be marked. And that might be part of the trigger that says that Alice's devices need to be removed. So I think that order of operations does need to be clear in the documents.
And maybe just one more comment on, sorry?
But I think it's important to maintain that, if we're going to have that preemption invariant, we need to make sure that Alice remains in the participant list, even if marked as exiting, as long as Alice has devices that are joined.
Yeah, I mean, that's partially due to an unfortunate restriction of MLS, where Alice cannot just do a commit that removes herself, because the committer needs to introduce new key material, and Alice needs to be removed from the group cryptographically, so she shouldn't be the one who samples the new key material and injects us into the group. And so partially, at least, it comes from there as well. But I think Richard's proposal is a good one, and that we should keep this invariant alive. Eric?
Yeah, I think that's thanks for that comment. I think that was exactly the sort of the thing I wanted to hone in on. Is it's the invariant that was proposed at the beginning is that if you're in that you can't be in the MLS group without being a participant, right? But you can be a participant and not be in the MLS group in the simple way that basically you haven't yet added. Is there any way in MLS to get back in that state once you had a client added? Mainly, so I was a participant and I added a client, and then my phone like explodes. Is there any? And I don't have a new phone yet. Is there any way in this infrastructure to get back to the once you ever had a client added to become a clientless, an inactive member of the group, or can you only go from inactive to active? You see what I mean?
I mean, you can go from active to inactive if you just propose. I guess if you have a different semantic for the whole user leaves versus the user just has his last client or their last client remove itself, like propose a removal. Like this is the example that Matthew, I think you brought up with the browser tab. I want to close my browser tab, and I don't have any other client, but I still kind of want to be in the group, and I want to be able to rejoin the group without having to have someone re-invite me. I still want to be authorized to be in the group. And so when I close the browser tab, it sends a leave proposal, and so the next person then kind of removes the browser client, and then I'm in an active. Is that what you meant?
Yeah, I think so. Yeah. Because I mean, I just worry. Is there like so? I think that like, do we want to? It seems weird not to preserve that invariant, but maybe it's okay. I don't know. Like, I mean, I think I like this browser tab example because it seems like it's like a good security practice to not have this like information. I don't know what you call it. I guess you call it like some kind of PFS effectively, right? To be like, I'm no longer part of the group, so like, why are you still encrypting this key, right? So I don't know. I'm just trying to think about like, is there a way to get back in that state that doesn't involve kicking yourself out of the group proper? I don't feel strong about it. I'm just trying to wrap my head around it. Thank you.
Yeah, I think the answer to that maybe depends on if we want that as a feature. Like that's kind of a more of a producty question rather than it's not a question of can we do it, but do we want to enable it? Okay, if there are no more questions, then Richard, yeah. I can't hear you. I think your camera's on, but I don't see the mute coming off in the meet echo. Oh.
Test. There we go.
Yep.
Yeah. No, I was going to kind of pivot us away from the examples to kind of broader discussion. I'm hopeful that at least a few folks have reviewed the documents in addition to the framework we've discussed here. If you've done both, you can see there's a little bit of a disconnect. So I think the question for the working group here is, if we think about what stuff we would want to adopt to start getting working on a protocol, are we headed toward the right foundations here? To what degree are the documents a suitable foundation, a state to be a foundation? To what degree are the concepts we've discussed here? If we were to take the concepts from this call and fold them into the documents, would be in a pretty good place to start adopting things. So yeah, that's the question for feedback, and I'll drop my camera and let the discussion unfold.
I guess I'm first in queue. So yeah, from my perspective, this feels like a really good compromise between the very sort of purist MLS approach that MIMI-DS proposed in San Fran, and the kind of much more pragmatic approach that we were taking on linearized matrix. I think we basically get best of both worlds here, in that we can benefit from the security properties of MLS whilst making it sufficiently pluggable that the E2E block can be removed and replaced by other transitional vendor-specific crypto structures, which again might not have the same quality of security properties, but can evolve in the right direction. So I basically really appreciate the work that the design team has done to try to accommodate this slightly controversial idea of a transitional approach. We've ended up working with a lot of the big messaging providers whilst this has been going on in parallel, and the feedback we've had there has been pretty positive in terms of something that would work both transitionally whilst also making sure everybody can end up on MLS in the end. It does have the whole confirmation approach of the red and the blue arrows effectively, but from my perspective, it's a complication that is well worth it in terms of the pragmatic win of how we get to the final end goal. So that's where I'm at.
Thanks. Ecker?
Yeah, so I think so first, thanks to the design team. I think that like this general architecture, I think seems like quite a good direction. I think the sort of like the layout, the sort of the architectural components seem sensible, but also the way in which they're put together seem sensible. Frankly, the documents are I would say a hard hat area, to be honest. I spent the time trying to read them and really felt it was really difficult. So while I think I think this is the right direction. I think maybe it'd be appropriate to do an adoption call for the MIMI architecture document. The other documents need a lot of work before we ready for adoption. And I think the bar has to be like you could persuade yourself you could implement this maybe with open issues as opposed to it sort of being a collection of open issues, which is really what the documents feel like in many ways. I guess what I would encourage, and I guess I'm happy to provide more detailed reviews, but I think we need at least one more of the documents before we do adoption for anything other than maybe MIMI Arch. And I think against the bar, like they should be self-contained, I think, and just to go what I was saying earlier, I think like we should look at merging them pretty substantially. It's just really hard to read them when it's like this thing is like pointing this other thing over here, and this thing is over here, and it's really hard to know, is this just not defined anywhere, or is it defined like in some other document, and not nowhere is typically the answer, but it's just extremely hard.
Thanks. Anybody else have thoughts on Richard's questions? Go ahead, Richard.
And for avoidance of doubt, I think that like I feel pretty good about the direction we've gotten to in the design team. I think Ecker's probably right that we need one more spin of the actual documents before we do an adoption call, but I think we could probably do that in another couple of weeks. Kind of take what we've discussed here, make the documents a little more concrete, and put something forward to the working group that would be in a more or less adoptable shape. But of course, would always be happy to have some more opinions in the room.
Yeah, it would be really good to hear from people, especially who are not on the design team, their reactions to what has been proposed. Yep, Ecker, you're the only one not on the design team who has chimed in so far. So, which is okay. Like, I mean, the design team is big in a way. So that's all right, but just want to make sure everybody has an opportunity. Okay, so let's maybe come around a little bit to the kind of the plan for these documents, because, well, first of all, if they are going to be merged, I'd much rather do an adoption call on like the 1 or 2 or 3 that we think they're going to end up consolidating down to, instead of like 6 and then do it later, because that feels like messy. So I would like to understand whether like people are committing to that and how that's going to work. From my own reading of them, I feel like that could be quite beneficial. I feel like there's a lot of inconsistency across them, and they feel very much like they were authored by different people separately. So that's one thing that I'd just like to understand from the author team here. Like, what are you going to do, and what's your sort of target set? Tim, did you want to jump in?
Yeah, speaking as, I guess, a working group member and not a chair, on the topic of like document consolidation, I'm very much in favor of consolidating them. Like over in the distributed aggregation protocol, which I'm working on in the PPM working group, we have a split there where like one document is in the PPM working group, and then it relies upon another document called VDAP that's in CFRG. So like that split makes some sense because it's across different like working groups, or I suppose working in research groups. But all the same, we found it to be like significant just admin overhead, having these two drafts to wrangle. And there's been at least one case where we messed up the submission of a draft because we forgot to bump a version number and whatever. So multiple documents is really just a lot of tedious admin overhead, especially when it's not clear, but it provides a big benefit. So I heavily favor having fewer documents.
Are you with us, Conrad?
Yeah. Okay. Sorry. Yeah, if I can maybe respond to that, at least for the, and I wrote this in the chat earlier, at least for the MIMI DS, I think it would make sense to have it as a separate document, because, I mean, as we all know, and I mean, that's why we're here, is that MLS is not sufficient to do messaging in any way, shape, or form. There are additional components required, and one of those is indeed a delivery service in some form. And so even though we're not chartered for this, having a separate, like a document that separately kind of describes the DS and defines the DS would be useful for people outside of this working group who want to use MLS, but who do not have the, cannot, come up with their own DS design, or then don't have to come up with their own DS design. And having some sort of reference DS in a more, in a more kind of in this modular way would make sense in my opinion.
Okay, Travis.
Yeah. So as the author of both the policy and signaling documents, I think those two specifically can be merged quite easily. Transport might be a little bit more difficult just because both the DS and remaining portions of the stack need a transport, but it is possible that could be, say, amalgamated into more of a MIMI protocol stack, with the DS kind of on the side. So I agree with that approach sort of idea where we can reduce the number of documents, but I don't think we can get it down to one, if that makes sense.
Becker.
I guess I just don't understand the argument for getting it down to one. Seems to be like we want to use this in some other place, and like, like reference the subsections of the document. I guess like like I'm just like really, I guess like I'd be more open to this if someone showed me a treatment that like actually was readable and was demounted in that way. But like right now, it's like incredibly hard to follow, and the most important thing is to be readable for this person's working group. So like if someone has a treatment that is like has maybe DS broken out and like otherwise is really readable, then like I'm like totally open to that. But like I want to see that rather than start with the assumption we're going to do it that way.
Yeah, just to reinforce Ecker's point about like referencing subsections, like we have a bunch of prior art with this in terms of people reusing serialization formats from Quick or TLS, despite those things being part of the relevant documents and not broken into separate documents. So yeah, I think this can work in either way.
Okay, so it sounds like on the design team, you have some agreement around some of the consolidation of these documents, maybe not all, but maybe you can work that out in the design team and come back with whatever the proposal is going to be when you come back with it.
I believe the clear feedback has been heard from the working group that fewer documents is preferable, and the more clearly fit together are preferable. So yeah, I think the idea, we'll take the feedback we got today, and stuff that was in the slides, get that folded into the documents from a technical point of view, get things more consolidated and working better together, and hopefully in fewer documents, and bring it back.
Okay. I think the other thing is, some of the documents still have like external references to what some of the content should be. And I feel like for the purposes of adoption, that really needs to get filled in. Like, even if there's like, whatever placeholder to do, like you haven't decided on the design yet and whatever, that's fine. But like, you have decided on design, but it's like referenced in a GitHub issue or something. Like let's fix that so that people can actually like read top to bottom and understand what's being proposed. That seems pretty important for adoption call as well. Okay. Now we're just going down my list of pet peeves as I was reviewing the document. So I'll go to the next one, which is, you know, we had, I think, a good discussion today about the integration with MLS and like flexibility for people to go off and do their own thing if you have an MLS shaped hole. So the discussion was good. I think, again, on this point, the way it's represented in the documents is at present is not really consistent with the charter of this working group. Like, because we said that we assume use of MLS for key establishment. So I think we need to be kind of pretty strict about like, that's our assumption. And so that's what we build and that's what we put in the documents. And like people can assume what they want and do what they want outside of that scope. But I think we also need to kind of ditch the language about how we're doing it purposefully to, you know, let people use other encryption protocols. Like it's not going to be timeless, and the RFCs, once they get published, never change. So we should take out all the stuff which is kind of like in the current context, here's what's happening, and just say what we're specifying and then specify it. So that's my other piece of feedback on the editorial changes to be made. Yeah, Matthew.
Yeah, I think that's reasonable, although it does tie into the previous point of consolidation, that I was to echo the desire for the MIMI-DS style end-to-end encryption block to be a separate spec almost helps articulate that interface for the unspeakable people who might want to swap out that Lego brick for equivalent Lego or an equivalent shaped hole. As in, it's easier if that is actually a hole with an interface that can be swapped in and out. So, whilst I totally agree that there should be more consolidation, and I agree with Eka that the current set of documents are indigestible when swallowed as a whole, I think there is an argument for keeping that one more modular.
And just by way of precedent, I note that RFC 9000 Quick is separate from RFC 9001 using TLS to secure Quick. So, like, there is some precedent here for creating the hole and then filling the hole.
Ecker.
Necessarily object to that, but like I will tell you that I don't think that actually worked out that well in Quick. I think it's actually like makes it harder to read the Quick documents when you read it that way. And there's like a bunch of like back and forth about where things really belonged, and the cut isn't as clean as you like. And like there's all kinds of things in Quick that basically assume properties of TLS. So I guess like if I think, you know, and like to be fair, like you know, TLS is like a protocol, like a really clear like externalized boundary, right? And part of what this document is doing was like, so I think, you know, again, like if this can be made readable, you know, with like the DS broken out, I'm like, cool. But if it's gonna like, and I think the test here is like, are you constantly trying to remember what the properties of the DS are in order to read the rest of the document? And then like that's bad. And if the properties are like no, it's like you can have a vague sketch of what the DS does, and then like read the rest of the document, then that's like cool. But like but if like there's just like a lot of back and forth in between them, it's just like makes it really hard to read.
I guess it's possible that the DS boundary specifically isn't the right one. It's more the different, well, it's the MLS shaped hole, which has some overlap with DS, but also the confirmation primitives, for instance, made available to keeping the participant list and the room state in sync with the underlying encryption group. So I agree with Eka that you shouldn't be sitting there thinking, what the hell is a DS and what is it doing right now? But it might not be that bad an abstraction to be thinking, and now, I don't know what the equivalent would be for that slightly higher level abstraction. It doesn't solve, of course, Conrad's concern about having MIMI-DS as a standalone thing that can be used as a pure MLS DS, irrespective of MIMI.
Yeah, I think those are all fair points, and all I can really say is that sure, we'll give it a try, and if it doesn't work, the MIMI section will then, I guess, just become a subsection, which can easily be done, I guess. So yeah, we'll give it a go, and you'll be the judge if it worked or not.
Sounds good. Then my next question is about the architecture document. If you want to keep that separate, and that one's been around longer. I know it got updated, but if we're keeping it separate, we could sort of poll for adoption today and confirm on the list. But if you're going to fold it in, then we won't do that. So
I think I would probably keep it separate. Yeah, I hadn't thought about it since we just started consolidation here. I think, yeah, I would probably keep it separate in the same sense that like MLS did an architecture protocol distinction. As in that case, also there will be some overlap in terms of overall, the overall logic of how the thing operates. They want to have some overview of that in the protocol document to warm people up, but also describe that in the architecture. I mean, yeah, I don't have strong feelings, but I would probably keep it separate.
okay.
I also think it needs to go ahead of the protocol docs in terms of adoption call headers. So.
I'm not sure I have strong feelings either, but I would probably merge it. I think it can serve as a nice introduction to a consolidated document, which I think like largely in retrospect, I think may have been better in other contexts too. So again, I'm not going to like fight strongly on it, but I think like the question is like how much material we end up duplicating. I think the question is, do you need to read the architecture document in order to read the protocol, in order to make sense of the protocol document? And if you don't, how much material they end up replicating between one and the other? So that may be something we should discover.
Matthew.
I'd say that the acid test from my side is if we have multiple documents, which seems fairly likely for the overall sort of mini set of RFCs, as it were, then from my experience, purely as a consumer of reading these, the benefit of having an architecture that gives you the high-level tour and lets you figure out which of the other RFCs you care about and what you should be reading is absolutely invaluable. And I think that MLS does, at least at the drafting stage, the MLS architecture draft helped a lot as I was navigating around MLS. So kind of +1 to Richard.
That's a good point. Rowan.
Yeah, ditto. Basically, like for me, a good architecture document is kind of the like, all right, what are we doing, and then the other documents are the how. So I do like the idea of an architecture being separate for that reason.
Okay. I think. Oh, Rowan, are you back in the queue? Oh, okay. I think, I mean, given that you're going to go back and do a spin of the others, we can revisit this next time when those are done. And if we want to do separate documents and separate calls, then we can do it at that point. I don't think we need to do it today. Okay, I think. Oh, Richard, did you have something?
Yeah, I was just going to concur and say let's just handle all of it together.
Okay. I think that's all the issues that I had in mind to raise on the design team. Does anybody have any further thoughts? Anything else to talk about on this? Okay. I was looking at the doodle poll results, and I think we have a couple of dates in October that are looking kind of good, maybe October 10th and 19th. So I'm assuming the 10th is too soon to come back to this topic, but feel free to get in the queue and tell me that I'm wrong. So if we schedule those two, then probably the 10th will come back to discovery, which we have lots more to talk about, and then 19th come back to this. But of course, like send us the documents whenever they're ready so people can review, and we don't have to have a meeting in order to move forward, but it could be a good demarcation point to get that moving again. That's kind of my thinking. Does that sound okay? Okay. Richard says it's good. All right. I don't think I have anything else. Tim, do you have anything else?
I do not, except I guess a note of thanks to the design team for all their work.
Yes, thank you very much. Really appreciate all the time you've been putting in. And thank you to Matthew for taking notes today. Check for email about those interims coming up, and we'll look for the design team documents. Rowan?
Thanks.
All right. Thanks, everyone.
Bye.
Thank you. Bye bye.